Hello, welcome to the channel. My name is Greg Friedman, and here I chat about science and frequently answer your questions that you leave in the comments below. And today I got 5 questions in one comment. So anonymous comment 5722, for some reason I think you're male. I'm not sure why, but somehow I think you are. If you don't mind, I'm going to call you Bob. It's just shorter. So Bob asks me 5 questions. I'll start with the first one. You've mentioned the antibiotic coating a couple of times. I imagine there is a wide variety of use cases for it in addition to your example of implants, maybe assisting in surface sterilization in food processing and medical environments. I'm curious about how common or uncommon it is, and what problems are faced with its adoption, cost, material limitation, unintended downsides. Well, Bob, that's a $5 million question. You know, one of the bloggers I follow some years ago said, anytime you come up with $1 million idea, it's a minus $5 million idea, because you need to find roughly, give or take, about $5 million to try to figure out if the damn thing works. So antibiotic coatings, yeah, we can do some awesome stuff, but, you know, disinfecting strawberries and disinfecting implants, you can imagine they carry very different requirements and have very different costs associated with them. Can we create permanently antibiotic, strongly antibiotic coating on a box of strawberries? Yeah, sure, no problem. But how will bacteria that are somewhere deep in the strawberry, in between the hairs, how are they going to get killed if they don't contact the box? So first of all, that really expensive box isn't going to do its job because bacteria aren't contacting the strawberry. So what we do today, just dunk it in bleach. Bleach, to the best of my knowledge, is just #1 use in the food industry. And medical device sterilization, yeah, sure, there are a lot of possibilities, but today medical devices are largely sterilized by gamma radiation, autoclaves, traditional autoclaves, where you use combination of heat and high humidity, and ethylene oxide. Ethylene oxide is dangerous, toxic, carcinogenic, mutagenic, corrosive, and horrible gas, but it works and it's cheap. So you have to consider price. The reason we went with surface aminization of PEEK is because the whole thing is very expensive. You have titanium implant coated in this highly durable, expensive polymer, and then you put a permanently antimicrobial coating on it. That whole process is slow and it's expensive, but it's a medical implant, so we can get away with charging for it. Whereas with food industry and many other industries, cost per item is much, much more sensitive. So plasmas, you know, I joke with people about this. If your question starts with, can plasma, 99 out of 100 times the answer is yes, but it's either too damn expensive, too slow, too complicated, or you need a bunch of PhDs to run it. So boils down to the cost of the process and the cost of current solution, keeping in mind when you're talking about disinfection of all kinds, the #1 solution in surface cleaning, #1 by far across all industries, it's cheap and it's fast, and it's easy. It's called nothing. It's widely used everywhere. You just don't do anything about it. Anyway, big competition for all technologies, plasma included. So, your question needs to get a little more specific product, like can we use plasma to sterilize your toothbrush? Yes, sure, no problem. Can we create liquid that you can swivel your toothbrush in to disinfect it? Yep, plasma activated water. Can we make a toothbrush that will have permanently bonded antibiotics on it? Yep. Sure, but it'll cost you. So what do you do today? Probably same as me, nothing. Guilty? Anyway, so let's move on to the second question. Is there any degradation of the treated material from plasma treatment other than the surface scratching? I imagine that there is some level of heat damage or maybe damage from current passing, like an electrocution. Oh boy. There are a whole bunch of different plasmas used for a whole bunch of different industrial applications. So each plasma has its pluses, has its minuses. There are very gentle, low-pressure plasmas used for surface coating deposition that either completely do not touch the surface or have very, very minimal interaction with it. And I think your next question will touch on that a little bit. But in general, there is degradation. Sure, we usually know what it is and we usually can control it. Etching is you purposely degrading surface. So plasma etching is a widely used industrial application for plasmas. And that is damage by definition. Your next question is the same thing. You're purposely modifying the surface using plasma. Whether you can refer to it as damage or not depends on whether you want to do it or not. There was a lot of work done about a decade ago in Italy on etching the surfaces with very, very precise patterns so cells can attach or not attach to those surfaces. I'm talking human cells, so it's blood biocompatibility treatments. Very cool work, and it's etching surfaces using plasma with a very specific purpose. So yes, you're damaging, but your purpose actually is to damage. So I hope that sort of answers your question, but again, to fully answer it, I need a more specific question, like what does atmospheric pressure dielectric barrier discharge treatment do to high density polyethylene packaging material? That kind of question. That one's like a specific one. I can tell you what plasma would do. Generally, yeah, plasmas degrade surfaces, and yeah, a lot of times we use plasma to do just that. So moving on to your third question. I watched a video recently, I forgot the source unfortunately, that mentioned plasma nitriding of steel. The process seems really useful as it can be used on top of other methods of changing the material properties and seems quite low risk in terms of damaging the object. I'm curious on your thoughts of plasma nitriding. I don't have any. I usually don't work with low pressure plasmas, and nitriding is done using low pressure plasmas typically. It's used for material surface modification, to modify material properties, and it's like metallurgy. I don't really do much work in that direction. I just haven't, especially working with, I'm a lower TRL, the technology readiness level. If you don't know what it is, NASA uses technology readiness level scale from 1 to 9. 1 being, oh, I got an idea. 9 being, well, that idea is now orbiting Mars. So your technology goes from 1 to 9, and around 5 is where technology exits the lab, exits the bench scale, and starts entering industrial applications. First steps in that direction. I typically work between TRL 2 and 5. So I'm in the lab scale thing. And when you're talking about nitriding steel, that's already heavily industrial applications. So in the industry, I've never done that work. So I don't know how to answer your question. Besides the part of the question that, yeah, it's quite low risk. It's typically used because it does better job faster than current nitriding processes. And yeah, so moving on to your next question, which is very related. Are there any other uses of plasma similar to plasma nitriding, in which plasma is used to diffuse something into an object rather than etching or deposition? Well, yeah, I mean, plasma for surface modification is widely used industrial application. So you can remove things from the surface, or you can add things to the surface. Now, diffusing things into the surface is kind of in between, or kind of to the side there. So plasma is widely used for all sorts of etching, controlled removal of material, anything from cleaning of steel to removing road markings on the road. Believe it or not, we did that with plasma. It's pretty cool. To microelectronics, so you etch the surface. Or you can use plasma to deposit things on a surface. Diffusing things into the material. Plasma's, to the best of my knowledge, and again, this seems to go outside of my domain of expertise, but we typically don't do that except in medical applications, and in biomedical, I should say. So in biological applications of plasmas, diffusion of both plasma-generated species and the effects of those species becomes quite important, and plasmas are very widely used for that in biology and in medicine. What I'm talking about. So plasma is usually gas phase phenomena. You take an electrode, you treat your finger, and then a bunch of stuff happens inside of your finger. I believe I did a couple of videos on that. I'm happy to chat about that specifically. But in general, you can say that the entire field of plasma medicine and plasma agriculture relies on diffusion of plasma-generated stuff into the material, being human body or cherry tomato. So yes, very widely used, and again, happy to answer a more specific question. And finally, your last question. What do you reckon is the easiest way a normal person could play around with plasmas? I'm thinking of something within reach of a hobbyist or backyard scientist, although not too many people have backyards nowadays. I agree with that. Off the top of my head, there's playing with microwaves, not something that I'd recommend or I'm keen on myself given the danger, but there's plenty of different things possible with it. Egg microwave grapes and fire, or collecting fluorescent tubes. Cool question, man. Yes, I think so. I don't know. I have a plasma ball over here. There's the plasma ball. It's off right now and the cable isn't long enough, but this is a toy. I never even turned it on. I just kind of have it here. So if you want a cool toy, this one's awesome. Got it on Amazon and it's like 20, 30 $30, and it's big and it has plasma. it's more of a fun toy. And you said easiest way for a normal person to play around with plasmas, meaning control them. Go on Amazon and just type in plasma. So there are plasma cutters, hobbyist level or pro hobbyist, prosumer level plasma cutters. There you can go to Home Depot or Amazon and get an actual legit plasma cutter. That's something you can play around with it if you're cool with high voltage torch and molten metals lying everywhere. I mean, not in my backyard. I wouldn't. There are a bunch of plasma toys, some of them really cool. But you asked if a person could play around with plasmas. I would caution. Just like you're concerned with microwaving grapes and such, microwave is a pretty powerful thing. There's like a kilowatt transformer in there. It's a lot of power, and if you use these things in the wrong way, you make a mistake. I'm terrified of plasma even more than I'm terrified of my table saw. Doesn't mean I'm not going to cut wood with a table saw, but every time I do, I try to do it really carefully, and I make mistakes. And so far, knock on wood, so far I haven't had any accidents, and maybe I haven't had them because I'm careful. But I don't think plasma is something you should carelessly play around with. If you search on YouTube, I think there's a channel by Plasma Guy, I think he calls himself, and he talks a lot about different cool plasma things you could do at home with fairly inexpensive toys. If I find his channel, I'll link it in the description. I'll try to, but you can just search Plasma Guy. I think that's how I found him. And yeah, I mean, for fun, just buy one of these, or on Amazon, there's a bunch of different configurations of these. They're flat ones, really big ones. There's ones, like you said, they're neon lights. So for fun, and just to say, oh, that's plasma, yeah, get a toy. But if you actually want to play with plasmas, be careful. Be careful. I would watch a dozen videos on how to do something before doing it. And it's not so straightforward to learn these things because high voltage tends to bite you in the butt when you least expect it. You didn't ground the power supply correctly, and it's grounding itself to the table, and your table is metal, and you happen to touch it. The table, not your setup, the table. Ouch, that one hurt. I actually had a hole into my nail. Yeah. Be careful. So, are there things you can buy and play with? Yes. Word of caution. Be careful, and at least watch a bunch of videos and ask ChatGPT how to use that tool. But Bob or Anonymous Comment 5722, thank you for your 5 awesome questions. I hope I answered at least partly, and I'm happy to answer more questions. Please post them in the comments below. Peace. I'll see you in the next one.